Hello everyone, welcome to the video lecture on errors and the compensation in wattmeter. So in the previous lecture we have seen the operation of wattmeter, that is electrodynamometer, and we have also seen how the power can be measured, the calculations of power. In today's lecture we would see what are the possible errors caused in a wattmeter and how we can rectify them. So the first error that is caused is pressure coil inductance error, and we'll see what is that error and how we can rectify it. So in a normal ideal dynamometer type wattmeter, the current in pressure coil is in phase with the applied voltage, and we all know no instrument is an ideal instrument, and so uh, definitely there would be an error. But in practically, the pressure coil of the wattmeter has an inductance, and because of the inductance effect, the current in the pressure coil will lag behind the applied voltage. So if there is no inductance um, present in the current in the current pressure coil, then the current in the pressure coil will be in phase with applied voltage, and in the absence of inductance in pressure coil of wattmeter, the readings will be perfectly fine in all power factors and frequency. But the problem is there is always a small inductance that is seen in the pressure coil. So what happens is the wattmeter will read high when the load power factor is lagging, as in the case the effect of pressure coil inductance will try to reduce the phase angle between the load current and the pressure coil current. So this is a very serious error. Or otherwise what would happen is the wattmeter will read low when the load power factor is leading. In that case, the effect of pressure coil inductance will try to increase the phase angle between the load current and the pressure coil current. So hence the wattmeter will read low. So this is also a series error. So because of inductance, there are two possible errors. There are two possible means of errors that could happen in a wattmeter. So the first case is when the load power factor is lagging, the pressure coil inductance will try to reduce the phase angle between load current and pressure coil current, and it is because of that the wattmeter will read high. The second case is when the load power factor is leading, the effect of pressure coil inductance will increase the phase angle between the load current and the pressure coil current, and it is because of that the wattmeter will read low. So both these are serious errors, and it will affect the readings in the wattmeter. So what can we do is inductance of a pressure coil can be reduced by placing a capacitor in parallel with the series resistance, that is nothing but a multiplier. So we know capacitor will produce a lead behind the applied voltage. So that leading phase angle will cancel the lagging phase angle of the inductance, so it will become neutral. The other possible error that can happen in wattmeter is error due to pressure coil capacitance. So in the previous slide we have seen what is error due to pressure coil inductance. So we have seen the inductance effect will produce a lag in the applied voltage, the phase angle lag in the applied voltage, and it is because of that the wattmeter can read low and also high, and that causes error. But if the inductance effect is there in pressure coil, in the same way if there is capacitance effect also in pressure coil, then there is no need of additional capacitance that we placed in pressure coil in parallel with the multiplier, because the effect or the error caused due to inductance will cancel the error which is caused due to pressure coil capacitance. So the inductance effect and the capacitance effect will cancel each other, and the error will be nullified. But suppose in case if there is no inductance effect in the pressure coil, then obviously there will be an error produced because of the capacitance effect. And the next error is a temperature error. So we all know any changes in room temperature will subsequently change in the value of resistance. So the stiffness of spring provides controlling torque. So the value of controlling torque and the change in the resistance because of temperature will cancel each other. So because of the because both the changes are opposite in nature and they cancel each other. But we should not tally this effect. So because we need stiffness of spring to produce controlling torque, and they should not cancel each other. So in order to reduce the effect of temperature in resistance, we need to put a resistance which has negligible temperature coefficient. So thereby the resistance value will not change due to change in temperature. So the next possible error that can happen is error due to mutual inductance. So error may happen due to mutual inductance between the pressure and the current coil of the wattmeter. So the errors are minimal at low power frequency, and these errors are maximum when the frequency increases. So what we can do is, this effect of mutual inductance can be avoided by arranging the coil in such a way that they don't have any mutual inductance. So in this way we can avoid the error due to mutual inductance. So one way of arrangement is the dry state torsion head wattmeter, where the arrangement of wattmeter is such a way that there is no mutual inductance effect. And the next error is eddy current error. So what is an eddy current error? We know eddy currents are produced because of alternating magnetic field. So eddy currents are produced only in solid metal parts within the thick conductors. So this eddy currents are produced because of the alternating magnetic field, and this causes variation in the main current in the current coil. So the way to compensate this is, the error can be minimized by avoiding solid metal parts. So instead of solid metal parts, we can try using stranded conductors for high current applications. The next error is stray magnetic field error. So what's a stray magnetic field error? So we know electrodynamometer type wattmeter has poor operating field, and whenever there is a stray magnetic field, that is magnetic field produced apart from the wattmeter, it will cause serious error. So in order to avoid the stray magnetic field error, we can easily shield the instrument so that the stray magnetic field can be avoided. And the next possible error is errors caused by vibration of moving system. So the torque on the moving system varies with frequency, and it is twice that of voltage. So if the parts of the moving system has a natural frequency which is in resonance with the frequency of torque pulsation, so we know any moving system will have a frequency, a natural frequency, and it will synchronize with the frequency of torque pulsation. So due to that, the moving system would vibrate with a considerable amplitude. So this considerable amplitude will cause vibration and it will produce errors. So these errors can be reduced by properly designing the wattmeters. So these are the possible errors that can happen in a wattmeter, and we have different compensation techniques also in order to reduce this errors. The above topic is taken from the textbook A.K. Sahani, a course in electrical and electronic measurements and instrumentation.